predicting if a precipitate will form. Well, let me just kind of tell you my reasoning, and then we'll kind of talk about the words that it has below. And so the way I think of it is when you multiply these values out, these concentrations out, if you get this number, the KSP, if you get that number, then the solution is saturated and it's not forming more precipitate, and it's nothing else is dissolving. It's the situation where you have some solid and it's kind of it is dissolving and recrystallizing at the same rate. So if when you multiply those out you get that number, you're at saturation. Okay, if you do something and you add one of these, say, and you multiply these concentrations out like this and you get a higher number, it means that precipitate is going to form. If you change these concentrations such that you get a lower number than this, then it means that more could dissolve. It's not saturated. So this number to me represents like the borderline of what is saturated when you have this equilibrium between solid and dissolved ions. Okay, and that's what I just said is what all of this is about, but I'll use these terms and stuff. So it's the same idea. Remember, we used this QC before as a way to predict which way a reaction would occur. And so in this case, we call it the ion product. And so the ion product is this. But those numbers are not necessarily equilibrium concentrations. That is the QC. Okay, and so we can think of that as like an initial. And then the KSP is when they are equilibrium concentrations. And this is just what I was just saying, that if you multiply these out and you get too big of a number, then the reaction will go this way and you'll get a precipitate. If the QC is too low, then the reaction will go this way and precipitate will dissolve, or more precipitate will dissolve. And if they're equal, then it's at equilibrium and the solution is saturated. And that's really what I just was saying, honestly. But anyway, those are the terms for it. If I want to predict when a precipitate will form, what I will be doing is saying at what point do I get to this number for my ion product. In other words, when is that number equal to the product of these concentrations, because that is the point at where it just crosses from dissolving to overall forming another precipitate. That is the equilibrium concentrations. So when QC, so this is QC, if it's not at equilibrium, when you multiply those out and you get this number, so KSP, then the precipitate will occur if you add any additional silver ion. So when QC, when these numbers give you this, you're kind of at that borderline, and if you do anything to increase either of these, a precipitate will form. So let's write this down here. Okay, and there's not a lot of room. But anyway, so I'll plug in my KSP. That was given. And the silver concentration is what we're asked to find. And we were given a chloride solution. We were told its concentration. And so all we need to do is figure out what concentration here if we're adding silver from something else to get to this, up to this KSP. And so you just solve.